Welcome to the Level 2 video on Arithmetic and Geometric Series. Today we're going to start off by talking about geometric sequences, and let's recall a statement quickly about the geometric sequence. So each term in a geometric sequence is found by multiplying the previous term by a constant. So let's jump straight into an example. Consider the following geometric sequence: 2, 4, 8, 16, and so on and so on. What is the factor? Okay, so our solution is that the factor is 2. And this because if we look at the term and the term before it, if we multiply that term by 2, it gives us the next term. So the factor is 2. And more generally, we can always write a geometric sequence like this. A being the first term, second term AR squared, AR cubed, and so on and so on. Where I said A is the first term, and R is the factor. And just like we did with arithmetic sequences, we can calculate individual terms using the following formula. So an individual term, xn, the nth term is a times r to the n minus 1. Now if we move on slightly and talk about summing a geometric series, then the formula for the sum of a geometric series is the following. So the sum from k is 1 to n of a times r to the power of k minus 1 is equal to a times 1 minus r to the power of n divided by 1 minus r. And why is this true? Well, it's actually really easy to prove, so let's go ahead and do the proof. first of all, if we multiply the left-hand side of the above by 1 minus r, then that's the first step. So we can factorize out an a here, and we have 1 minus r, and we'd have 1 plus r squared plus r cubed plus everything in the middle plus our last term, r to the n minus 1, so that there are n terms in there, don't forget. So let's go ahead and multiply this out. So we'll leave the a out the front, and we'll deal with the 1 times the expansion first. So we're going to have 1 plus r squared plus r cubed plus everything in the middle plus the last term. And now let's incorporate the minus r. So we're going to have minus r squared minus r cubed minus r to the 4 minus everything in the middle, and then minus the last term, which is r to the n. And then we can see what cancels. So r is going to cancel with r squared with r squared, r cubed with r cubed, and every single thing will cancel in here apart from the last term and the first term. So we're left with a times 1 minus r to the n. Then this implies that 1 minus r times the sum starting at k is 1 to n of a times r to the power of k is equal to a times 1 minus r to the n. So if we divide both sides by 1 minus r, then this will cancel, and we've got exactly what we want. So the proof is finished. So let's go on and look at a quick example of this. Calculate the sum of the first 10 terms of the geometric sequence, where the sequence is 3, 12, 48, 192, so on and so on. Okay, so our solution is going to be the following. So what do we know? We know that a is 3, and we know that r is 4. So the sum of the first 10 terms, so the sum is going to be 3 times 1 minus 4 to the power of 10, all over 1 minus 4. And if we put that into a calculator, we get 1,048,575. Thanks very much for listening.